Welcome to one more case study of our digitalization journey video series. Here we explore how real manufacturing companies are embracing digital technologies to redefine the way they work, innovate and grow. Today's case study is with the company Takumi Precision Engineering, based in Raheen, County Limerick. And we will hear from CEO Donna Galligan and COO Michael O'Neill, who will tell us about the company's digitalization journey.
When I joined Takumi in 2000, there was only 5 employees. Now we have over 120 employees working over a 2-cycle shift. Takumi was a small subcontractor manufacturer, basically doing small jobs. We grew through the years. In 2008, we started growing more into aerospace, and that's where we've seen our growth. We are now a subcontract manufacturer specialising in aerospace manufacturing, in first-class seats, structural components for aircraft such as wing and fuselage. It makes up about 60% of our turnover. And we also do medical device, so we do everything from hip, knee, shoulder implants, associated instruments, cardiovascular aids, and that makes up about 40% of our turnover. Takumi stumbled upon digitalisation. It was really from a need point of view. We had a new customer in aerospace, which was very high demand, wanting updates on a regular basis. And this proved quite difficult, that we had a lot of data that we had to input into our ERP system, but there was so much data there we couldn't see the wood from the trees. We had a lot of scenarios where the customer was sending in so many orders at the time we couldn't actually process them fast enough. So that's where we stumbled into digitalization. We had to look at ways that we had all this data out there, but we couldn't actually digest it, we couldn't see it, we couldn't use it.
We took on digitalization, number one, to reduce the burden on the business for aspects of the business that the customer doesn't pay. Data collection, data analysis, the customer doesn't pay us for that. We also took on an ERP system in the business, but it became very IT intensive. So it required a lot of experts and it was difficult to navigate. So to make that easier, we developed a digitalization system to visualize the data and make it easier for people to interact with. Our original systems were paper-based or ERP-based, and we couldn't capture the data. Someone had to bring information, write it down, bring it to somewhere. Now we capture it live at the machines. Initially, it allowed us to track the parts, so we can now tell exactly in the business where every part is. It allows us to capture the time taken to process that part and how long the time is spent in that part, not necessarily the same thing. So it might have taken 2 minutes to do the job, but it's set at the machine for an hour or a day. So now we can see that, and now we have data to analyse and to improve.
Yes, I suppose digitalisation has helped me in my role an awful lot. I think it has made things a lot less labour intensive. So one of my main roles would be to communicate with customers, and on a daily basis they'd often ask, where is a certain part or at what stage of the process is it at? By allowing me to click into Mado, it helps me to be able to identify which parts are at which stages on one click. This allows us not only to give them quicker information, but to know internally and help us plan better as well if certain parts need to be prioritised.
Mado is the Japanese for window. So it's an opportunity to look into the business and all the detail within the business. So it's a visual aid to our ERP system. So with targets here, once again, you have all your machines here on the left, and you have your different days. So essentially this is your queue. So if we start off with the TTBs, you have here the operators will come in, they clock into their machine. So you can see here, operator is clocked in and he has an hourly target. So this operator knows when they're leaving the pit meeting, they know what their target is for the day. Before Mado, we would have had a system, but our system would have essentially been a whiteboard. And on that whiteboard then you'd have your machines written out, but then you'd have post-its. So for instance, the seal housing, that would be a post-it, and that would be written, any details would be written on it, so on and so forth. You just have essentially a whiteboard full of post-its, and these might have been moved on or up and down if they were moved machines. So you can see here straight away, it's just obviously more effective, more efficient to have this. This is all live information instead of moving around post-its.
Working with the likes of TOOS is essential for us, it really is. Because it gets us to think differently. We're very much insulated when you're inside in Takumi. You just think that this is our own problem. This problem doesn't exist anywhere else in the world. And when you start working with TOOS and seeing what they're doing, it really gives us solace, and we know we're on the right track. And the advice that we get from the guys is invaluable, it really is. Like, they've been all over the world, they've seen this. And I'm a strong believer that Ireland is top of its game in what we do on this kind of stuff. We really are. There's a big fear how difficult it can be. to use the data, how to extract it out. And it is just literally there. It's just a matter of you taking it out of the cloud and using it. And I think that's probably the biggest challenge, that they don't know where to start. They think that it's a big project, that they have to get very technical people to pull that data out, when it's not that hard. And how quickly you can do it is amazing for us. And I think a lot of companies don't realize that. They think it's a big challenge to go and get that data.
So what we recommend with companies is that we first do a benchmarking exercise. So we look at their digital maturity. We look at all the aspects of their business in terms of where they currently are in terms of digital technologies. We also look at what are the business drivers, what are the metrics that they use. And really any digitalization initiatives have to improve those business cases. Typically in the first instance, it's companies looking at just using data better. So getting data from the factory floor, getting data from their suppliers, from their process, and using analytics and using data to show them better insights into their operations. Then they often move on to more advanced digital tools, which might be robotics, automation, might be applications of artificial intelligence in manufacturing. And then that depends on the circumstances of the company as to how much benefit they can get from those.
Something that Takumi has been very strong with over the years is taking in students. They come with some knowledge, they come with loads of bright ideas, we give them a bit of education, but they also get tasks done in areas where they've already got skills and we don't. So we don't have to invest in training somebody up, we don't have to worry about how much they know. They already know the skills, they take on a project for us and they get it done. And they have enthusiasm. Through collaboration with TUS, a research student doing his master's came on board with us and developed a digital twin for our surface treatment plant. And it opened our eyes to the possibilities and the capabilities of digital twin. He virtually created the machine in production and was able to point out to us bottlenecks that we created in our automation without knowing, because we had no experience in it. So that was the very first introduction to a digital twin system, and it was eye-opening to us. How could we use that in the rest of the business? Where are the gaps we haven't seen in the rest of our business? If we can do this on something we've just developed, what's it going to show us in the rest of the business?
Part of the digitalization of production module, I developed a digital twin of their plating line. Essentially what happened was the automation engineers, mechanical engineers were given a specification on the process and all the timings and how they wanted the process to work. I was given the exact same information, so I had to do the digital twin in parallel to what the automation people were doing. There was a problem of queuing on the line. What queuing is, each tank is in series. So what happened was the product went to the first tank, then the second and third and so on. But the anodizing tank had a time of about 30 minutes. And that meant then that all the product would back up on the previous tanks. And the exact same problem was identified in the digital twin as well. After meeting then with the Takumi production people and process engineers, there was strong belief that it was very unfortunate that we didn't build a digital twin prior to the automation people working on the production line, because it would have saved an awful lot of time. That if we had identified the issues very early on, instead of the next step or next part of the process of building the line, it would have saved 10 times the cost. If it was fully in production, it can go up to 100 times. So this multiple of cost for having to redevelop the line to iron out these issues could have been taken out at the very start of the process if the digital twin was used at that point. The digital twin, there's a couple of different functions for a digital twin really. The part that we used in the company with Takumi was part used during the development of the process, but it can be used in a number of different processes. Essentially, if you've got a full digital twin, you have your model of your any object, any production facility, whatever it needs to be, and then you can have communication with that. So data then can come from whatever object or your production line or machine. It can go into the digital twin. The digital twin will allow you to use that information with different iterations. The beauty and benefit of a digital twin is you're not doing it on a physical line. So if you have a crash or something goes wrong on the twin, it doesn't do any damage. So that means you can do all your testing offline, different iterations, you can optimize your process, and then you can take your results from that optimization and go back to the physical twin, essentially, and then implement your changes and you have a much higher probability of your changes working and working effectively without the risk and cost involved.
I'm 100% sure we would not be the size of company that we are today without it. We would still be probably turning over 4 to 5 million a year with maybe 40, 50 employees. We're now turning over nearly 14 million with over 120 employees. Without going digital, we wouldn't have been able to do that.
Thank you for joining us. We encourage you to reflect on how digitalization can empower your organization, and we hope to see you next time.